and wanted to welcome you all to our design updates and Q&A call. Our plan is to have our design team's lead organizer, Mr. Dan Greiner. He's going to give some updates on designs and then introduce some of our team members and give you a little bit of insight on what we're working on. And after that, we're going to open the floor for Q&A questions. So feel free to type anything into chat and we will work towards answering those shortly. So Dan, take it away.
Awesome. Thank you. Thanks, Brother Doug. Most of the people on this call right now, I think, are probably part of those design teams, but I'd love to give you guys a little bit of insight into where these different projects are at. What are some of the future things that we're wanting to do and want to roll out to the community, and how we can maybe better communicate with you and make a more frequent chance to talk about all the many things that are happening. So we are at 22 days of working, and it's only been, I think, a week and a half since I had an open call with everybody, but our teams have been cranking. And I'm really glad I have a chance to be a part of such a amazing group of people who really want to do something good for the community. And I can't wait to share some of this with you. So first off, some of the projects that are in flight. One that you're all familiar with, probably terribly familiar with, is the face shields. And there is a small team of kind of super users. Justin, you're part of that, and I think you know a little bit better about the team members who are part of that. Would you like to talk a little bit about what you guys have been working on?
Yeah, so I'm gonna, at least for the people that I have in here that I can think of, because it's been a long day. Chris is on the team even though he's new because he's learning. We've got Aaron, we've got Guy, we've got Zoe, we got a whole bunch of people. We're working on the stack designs. We want everyone to be able to print overnight when they're at work. And we're fighting the little issues because Prusa's designs are great, but they crank up the speeds too high, and you don't want to run those consistently because we don't want to damage your hardware. We want you to. It's a marathon, not a sprint. But the team's doing really well. We're constantly bouncing ideas and figuring out how to try, but we're not there yet. We're hoping to have something that people can at least do a 2 stack by Wednesday. But the team is really working hard, and it takes time, and if any of you have high-end experience, let me know and we'll bring in.
And one of the big challenges there is, we have such a huge, group of skilled people who all are able to take on and are able to add value in a lot of these different areas. But the challenge is we still have to produce. we are the production facility and the R&D and the all these different parts, and the distribution and the delivery mechanism. So we probably have the most skilled delivery crew in the world right now. We have people with PhDs that are doing nothing than loading boxes. So every part of what we're doing is valuable, and I really appreciate those of you who are able to step up in all the different roles that you're in. Justin's team, we kind of saw that they were running this chat room and are able to really help run down problems. And we said, hey, can you help us identify some of these problems that the community is bringing up about stack design? So I want to thank that team for working on that. Another project that has been one that's been talked about a lot. Almost everybody has been asking about respirators, N95 style masks, 3D printed masks. We've seen them all over the internet. We see them being used in some places. Our hospitals here have almost across the board said no. And instead of saying, okay, well, they don't want it, so we'll just forget about it. Luckily, I had a chance to work with some really fantastic designers in the past who were already working on some of these things. And I wanted to introduce Skylar Livingston, who's been working on what we're now calling the Livingston Mask, whether he likes it or not. And it is a respirator with a replaceable 3D or a replaceable filter, and it will be injection molded. So it will be safe to use in hospitals. and have a replaceable filter media that will meet the specs of what hospitals will expect for their frontline workers. So Skylar, please talk a little bit about your project.
Sounds good. Hey guys, my name's Skylar. As Dan mentioned, I'm a designer here in Denver over at Link Product Development. Yeah, the project started a little while ago as a 3D printed mask project, but quickly evolved past a print. You know, we got some of the early prototypes here, and quickly realized that the printing wasn't going to cut it. So kind of moved over to silicone design, and I can kind of show you guys it here. But yeah, I've been working with Mark, obviously, who's the founder of Link Product Development, Alice, one of the engineers over at Link, and Bailey Van Etten, who's a fellow designer. So yeah, I can kind of show you guys. It's obviously silicone rubber. As Dan mentioned, we're gonna start looking to injection mold these. It has the buttonhole strap kind of design, which I know has obviously proved to be a little bit difficult to get a hold of. So what's nice about this is that it does create a really good seal to the face. It only has a few parts, so you can kind of pop the front off here. It has a little knob, you can pull that off, and it just uses kind of blanks of filter material. Right now I'm just using what they use for surgical masks, because it's a similar equivalent, thinner version of what they use on N95s. And then it has a little plate in the back here. So pretty simple construction, small little filter square. The idea is that you can wash and reuse the mask without having to throw away the entire mask, and that you can just swap out the filter material here. So that's what we've been working on, and we have tooling, kind of starting up this week, and we're hoping to make roughly 1,000 a day. Hopefully starting in the next few weeks. We're going through some different testing procedures and things like that to make sure that it's going to work the way we intended it. So, yep.
Feel free to be specific about that testing procedure that we have to go through, Skylar.
Yeah, so what we've done so far is what's called a fit test, which essentially verifies that the mask creates a good seal around the face and then around the filter material. But what we have yet to test is the N95 NIOSH testing. And so that will test the airflow through the filter, and then also the effectiveness of the seal up to the particle level and size that is required for this type of mask.
Yeah, and one of the challenges here, it's one of the reasons why this wasn't an open source project and we didn't have everybody working on it, is this is an FDA Class 2 device, which unfortunately takes a lot of extra testing and a lot of extra verification. We've been working closely with lawyers from Cooley, which is a product development or legal firm, and they are helping us with kind of wading through the legal aspects of how to roll out a product like this. We're not medical manufacturers, but we are trying to do our best job to create a product that we can safely put into hospitals, into medical professionals on that front line. So we actually have pulled the trigger on tooling for this product. It's already being tooled up as we speak. And like Skylar said, we will have a product next week. This is how we prefer to see Skylar all the time, right here, all masked up and ready to go.
Yep. So.
Thank you, Skylar, for sharing that. Anybody have any questions for Skylar or about the mask? Or should I wait until the Q&A portion?
Where are they you're doing the tooling, where are they gonna be manufactured?
So the tooling is being done through a company called Proto Labs, and Mark, I can't remember, they're Midwest, right? Is it Michigan?
Minnesota.
Oh, Minnesota. Yep.
Yeah.
Oh yeah.
Yeah. Don't you know?
Yeah.
Great.
Yeah, we've been working with them through Link Product Development on various prototypes and manufacturing runs, and so we know those guys pretty well, and they can move fast, so it's good.
What's the output going to be on a daily basis?
So we're doing a single cavity tool. So what we're expecting is probably 1,000 units per day.
Right.
The mask will have different sizes. So we're going with the medium first that will work for most. And then we also have a small and a large size because normal N95 masks, even the disposable ones, have sizes. It's just one of those things you have to do to get the right kind of fit. So.
And the filter material, or that you're just going to rely on cutting up surgical masks, or what?
So we have a few options there. We've done a lot of research into all the different filter materials you've probably heard of online, you know, sterile wraps and vacuum filters, HEPA filters, all kinds of things like that. We've also identified and located a few manufacturers of the raw material for N95 surgical masks, things along those lines. So we're going to continue to do some pretty thorough testing, so that the great part about, you know, so that you can have a few different options for this type of mask. That's the great part, is that it's really mostly a chassis to hold various different filter materials. So our goal is to put it out there with the filter material we believe will be accessible and that will work. But it still leaves the option open for people to cut squares of different filter material and use it how they see fit. So
Cool, thanks.
And
yeah.
So
Dan,
in-
I guess one thing before we moved on, I saw Colleen posted a picture. It looks like a video of the Montana mask, and was just wondering about 3D printing that. It looks like, so if you wanted to address
Yeah.
really
So
quickly.
the Montana mask is it's a great mask. It is not something that hospitals want on the front lines generally. So that is using a laser sintered nylon, I believe, or a powder printed material, which is cleanable. But again, we're talking about an extremely slow, extremely expensive approach to creating these. There's some that have been printed out of other materials, but the porosity of the material, the inability to clean it long term, really presents an issue for those types of products. So the only real solution that we could identify was to spend the money and get a tool made so that we could create these in volume. Because the additive process, as you all are very well aware, is a slow one. And while what people are creating is valuable and useful, the problem is bigger than we are able to tackle with just 3D printers. We need more. We need more things.
So is Make for COVID then paying for the tool?
We are. We use
And that's
donations.
done through donations, yeah?
Yep, it's all through donations. We're not charging anything for it. It will be donated to the hospitals, much like the rest of the products that we create.
Has anybody gotten a Facebook donation button set up yet? Because I keep getting asked about that. I just keep sending them to the website, but I think there's some, some advantages to the heart,
Mm-hmm.
Somebody sees something immediately, a nice picture on Facebook, and they're like, oh yeah, I could give $100.
I think we do put links to our groups that makes it easy for people to donate. I know we're not doing it specifically through Facebook because of the way they actually hold the money until the end of the campaign, which would make it pretty hard for us to operate with. Yeah. So that was a challenge we saw early on, and we're like, wait a minute, if we can't use any of this money until we're finished, then we're really in trouble. We'll be screwed. So anyway, another thing I should mention about the Livingston mask, Hayden McLean is also online. So the UC Health Department really wanted to take this product forward as well. And we're hoping to use it as a backup for their frontline doctors. And they have also tooled up a small version of this product. So that is another part that will be getting created as well. But we have a bunch more products to talk about, so I want to keep moving. One of the things that doctors early on identified as a huge problem was the protection that they use when they are doing intubation. And what they do, they wear a thing called a PAPR hood, and these PAPR hoods are positive air pressure respirator. So they are a product that it looks like a big hood. It goes over the head with a shield, You've probably seen them on every disaster movie on Netflix. But these products are in short supply. Most of the hospitals only have, half a dozen of these units. And it was identified really early on that they needed these very badly. So we've got a team that is taking on the hoods themselves, the soft good piece that goes over top of the head, and then also the PAPR pumps. So these units usually go for about $1,500. And we are looking at creating something close to 200 or 250. So we've been able to bring down the price of that product and create something that's useful to them. So I think we have Eric Gilger. Is Eric Gilger on here as well as Andrew Walla as well? Did he make it over? Okay, and Roy Swanson as well. So we have several people that are working on the hood part of it. Eric, Roy, can you guys speak to where that project is at and what's happened most recently?
Yeah, Roy, you're on mute, but you want to kind of talk about what you guys accomplished today?
Yeah, I will. So we have a soft goods consultancy here in Denver, and we end of last week we prototyped a hood based on Andrew Walla's kind of initial visualization of creating a hood that is only a single seam down the back, wrap around, and has it fixes to the shield on the cutout window that fixes to the shield, and the shield pops onto the headpiece or the crown. So we took that pattern and made some adjustments to it to make it as user or assembly friendly as possible, not knowing for sure who we were going to have assemble this, but then just to minimize time and complexity, try to keep the seam straight in the back and down the back. It's sealed with Tyvek tape after it's stitched. We opted for, we did surge stitch at first, but we switched to just a straight stitch since we're taping it anyway, just for the simplicity's sake, and open up our opportunities for a manufacturer too. So, because almost all soft goods manufacturers have just a flatbed walking foot they can stitch these with. It's 2 stitch lines, rolls around, 2 stitch lines, taped. The shield, we also adjusted it so we could tape the shield flat without any curve or any bunching, so it's just a really clean platform. There's one piece of the 3M 950 double-sided tape across the top to really seal where the crown pops into the shield. The shield's been redesigned too. I don't know who was responsible, if that was Dan or who did that, but it has the crown
last minute
headpiece. Last minute has a head. I could tell by the way the vectors went.
Thanks so much.
And the little radius.
Hey, shut up.
I was like, Dan was in a hurry. So that gives the proper clearance above the head for the ventilation, and then the actual soft goods goes above 2 for a little ways, just so that we can have room to assemble all this flat, get the tape to lay really flat so we can get a good tight seal, and then you can turn the whole thing inside out. Cutting the pattern takes longer than assembling the thing. We can make one in about 5 minutes, soon after the pattern's cut out. So, we have a factory, they'll cut a stack of patterns out with a jigsaw, probably have to click the out. So there'll be some initial costs potentially in making that die. We had a quote today, I think it was for like $9 for one, which seemed high. Dan and I haven't talked about that yet. It feels like it should be about $4 maybe, because we're bringing the material. So like, I think tops it would take them $10 10 minutes to assemble one. So if they've got, that's one person assembling one 10 minutes. So I just think that she doesn't totally understand the project yet. And Alberto, who's her brother, who has a different factory, he'll be sending quote too, unless he has already. So it'll be interesting to see how he comes back.
Play the brother against the sister, breaking apart.
Yeah, I mentioned to him that we were talking to Martha too, but I didn't mention it to her because I think that his operation's a little bigger. Not by success. I think that's just how he chooses to run it. And they do a lot of work for Topo, and so it's both decent, good factories, and they're both good people. So I think hopefully Dan can work his magic and explain to them the situation, and we can, even if they don't want to bring their price down a little bit, if they could give us just their labor at cost. But there's I think a potential there. I think you should work on them for that, because I think it's worth the conversation.
Yeah, we're not done with the pricing part for sure.
No, I didn't figure you were. So that just all happened today. So we got Ken came, he brought us material today, and he waited while Tom and I we just cut patterns and got them sewed up and taped up. Updated the pattern and uploaded it to the page, just so everything was up to date with what people have. A few tweaks with the size of that, so we get good overlap of the hood to the shield. And he took one to Alberto, and I think he was going to take one to Cinco, so they have one of those samples. We made 7, and they'll be, I think, just kind of another round of testing. They'll probably counter sample it once they get some material. And I don't know who else you might be talking to, Dan, to get those made, but I was really happy with how quickly they responded.
Yeah,
because that's, I guess, atypical to have a response.
I think they need the work right now. But so that's one part of it, right? Creating the prototype. The second part of that with these prototypes is getting them into the hands of clinical, users. So Ken Malone has just recently joined our team as of last Thursday, and he is really heading up our clinical interface. And he was previously in supply chain, and we just outright stole him from that department because he was so effective that we had to have him. I needed that kind of effectiveness under me, because I am not. So Ken is adding a lot of help on that side. Ken, can you talk about some of the reactions you received when you were showing that prototype?
We showed to 3 doctors, and they were all highly impressed. I mean, we went to 2 of them that are known for being very critical up front. They just don't have much time. But they did put them on and expressed a lot of comfort with their range of vision and range of motion, and some real hope for being able to use these things quickly. So I'm so glad that we're so far along in the design and approval process, that evaluation process, that it really looks like we could get into production pretty soon. I hope that we can beat the Papper Pump team.
Yeah, absolutely. Yeah. After this call, we'll go ahead. Sorry, Ken.
It really was a very positive reaction, and they can't wait to have them.
I'm not sure that we have to get permission from the doctors that we actually interviewed, but we do have pictures and video of them trying out these units. We have to confirm that they're okay with us sharing their likenesses and make sure no patients are in the background as they're doing it. So we have to vet those out first. But thanks, Ken. So the hoods are well underway. We have the material here as well. That's something we ordered weeks ago and has now arrived. So as soon as we get a contract manufacturer who can meet a price that we think makes sense, we're going to hit go on that. We've already also engaged our legal counsel to make sure that what we're putting out there and what the way that we are handing over these things does not incur any kind of liability. The second part of this was the Papper pumps, which is a really complicated project. And I think most of the team who's working on that is on this call as well. That's being led by Miles Keeney-Ritchie. Miles, do you mind talking a little bit about how that project's going?
Absolutely. So the pump is what delivers the clean air up to the hood. In its basic form, it's relatively simple. There's a filter and a blower that draws air through the filter, sends it up through a hose, and then delivers it into the hood. But because of the sort of mission critical nature of the product, it's important to have alarms for low battery or alarms for problems with the pressure in the high pressure side of the system or the filter life, which add significant complexity. So the main goals of this part of the project, since we are not going to get traditional FDA approval, we still need to deliver a product that we can convince the doctors and the hospital administrative staff is safe and protecting them, and we actually do want to protect them. So there are other PAPR designs floating around, and we've looked at a lot of them and drawn the useful things from them, but one of the main focuses of this project is to really put real engineering behind the decisions and into the details to make sure that we're confident that it's actually going to protect the medical staff, and therefore can back up our statements when we're taking these out to the hospitals for use. Another focus, since it's an electromechanical product, a lot of our typical manufacturing processes are not viable at these volumes and with our schedule and with our budget. For example, a lot of injection molded components. So one of the things that we've been focusing on is working through how to adapt the components to be made with smaller volume manufacturing. So the project is a little over 2 weeks in, and we've spun up an electrical design. Ty, our electrical engineer, has done a ton of work building a schematic and a layout, and released the first board to be fabricated today. So we should get that back soon. John and Dallas, our mechanical engineers, have been cranking away at the mechanical design, which I'll show you guys in just a second. There's a lot of nuances in there, sort of the same problems that Skylar was talking about, where we have to ensure that there's a seal in several places, because the last thing that we want is to draw in contaminated air or just leak clean air, because that doesn't do anyone any good. Pierce is our sourcing guy. You'd be surprised how simple the project sounds and then how complicated it gets to source all the components, especially with the supply chain in complete disarray, and trying to source components that are going to be available, in the future and to other groups, should other groups decide to build this. So Pierce has been doing a ton of work to try to find the right parts for us. And the last, major component to this is software. There's a microcontroller in it that handles the alarms and the running the blower, and it's not super complicated, but it has to work, and it has to work right. So Michael, our software engineer, has been writing software against dev kits because we don't have a board yet. So I appreciate him jumping in and getting some work done before we can show him anything. So let me see if I can share my screen and give you an idea of the renders. Oh, the host has disabled participant screen sharing, so you don't get to see them. But basically, the unit sits on a person's back, and we've designed the back, the open large face, to hold the filter and accommodate filters of different materials and thicknesses, because over the life of making this product, we're not sure.
He made you co-host, Miles, so you
all right.
You might be able to share. They just do that because sometimes I don't wear pants, and if I, yeah.
All right, so these renders are all John Grano and Dallas. Dallas, I can't remember your last name.
McKee?
I can't see one here.
Yeah.
I'll just throw it out for screen grabs, not real renders.
So essentially this, there's a square box on this person's back. The electronics are off to the right. It runs off of a power tool battery. And that way the unit, the filter unit and blower unit, can be in service the maximum amount of time. So if they get out of an intubation, they can swap batteries, and go right into the next one. The big grill on the front is where the filter is. The plate on the front can accommodate different filters, and it clamps the filter into place and creates the seal. Inside, oh, this is the electronics enclosure. There's some buttons on the bottom. There we go. On the inside, there's the blower, and then an adapter piece, and the hose plugs onto the top of the adapter that they run up into the hood. Generally, you put the hose in the hood and then on the unit when you're strapping the unit on your back. So there'll be some simple belt loops and a belt with a buckle that holds it on the wearer's back. Let's see here. So the basic status of things, we are buttoning up the last mechanical details, and that should get on the printer for prototyping either tonight or tomorrow morning. We're ordering components, we've ordered PCBs, and so everything is converging on building the first hand-built prototypes later this week. Then we've got to go through a round of testing and learning, and it's highly likely that each discipline will need to make some changes. If it's close, we may make the call that we can go right into production level parts. If it's far, we'll need another round of prototyping. We got to make that decision once we run the tests on this integrated prototype. There are a couple big blockers. At the moment, we don't have qualified filter material. And if we don't have filter material, it's not really worth sending this product out. So I know that there are a lot of people working on getting filter material, but if anyone has any ideas, shoot me a Slack message. The other thing is the batteries that we've spec'd. They have a lot of advantages, but they're also a final product and quite expensive retail. So if anyone has connections to Home Depot or Ace Hardware or DeWalt or any tool company, we are looking around for an in-kind donation or maybe having them sell the batteries to us at cost, because we would really like to have multiple batteries for every pump unit so that they can keep them in service as long as possible. We do have backup options like RC car batteries, but we'd like to exhaust our options looking for these before we jump into an alternate source like that.
Quick question about the filter.
Yep.
So there's with the face, and Skylar, maybe you can pitch in on this too. Like on the face, obviously the how easily you can breathe through it is a big factor for it needs a filter, but then you need to be able to breathe through it.
Yep.
So do we have a different pool of filters that we can derive from, since this is a motor driven? I mean, like with the idea of like a vacuum bag, trying to breathe through that is impossible, right? Or any other material, another source that we can draw from that isn't being exhausted by people who are making face masks?
Sorry, let me make sure that I understand your question. You're saying you want to make sure that we don't draw from the same supply pool and suddenly get in a bidding war with ourselves to try to...
That's another way to look at it. But just is there another resource that we have, since we have a machine driven, we have a filter that has a machine driven pump on it? Can we use a different filter that doesn't have to be, because the face masks can't, the kind of filters that would work, that would be effective, you can't breathe through it because it's too hard. But
I mean, from
a different resource that we could be drawing from that isn't already being exhausted by the face mask. I'm just throwing that out there. I have no study or understanding.
Yeah, no, I think that's a great thing from the from an engineering perspective. we have certain specs on the blower, right? And to ensure that the pressure drop across the filter is something that the blower can cope with, we just have to scale the area of the filter. So from an engineering perspective, it doesn't really bother me or matter to me, sorry, what the filter material is. So the way we're operating is whatever filter we can get and is trusted by doctors or approved by NIOSH, or whatever approvals we can get on it. Once we find an appropriate material, we can design the mechanical system to accommodate that.
Yeah, and to address your question, Roy, it's been a bigger challenge, obviously, to find filter material that has enough airflow for a mask. But we are finding suppliers and options for filtration material that would probably work for what you're talking about, Miles. If it is, if you guys are able to spec out exactly what you need, I'm assuming the filtration specs will be it will be harder to find something for a mask than it will be for the blower. But at the same time, I think connecting those resources and making sure that you're in that conversation as to what we're finding on the filter side would be really
that would
important.
be awesome. Yeah, I mean, really the critical thing is that it filters out the virus particles, right? Or the droplet particles.
Mm-hmm.
If it doesn't protect against the virus, there's no point in putting it in the product.
Yep.
If it does protect against the virus, we can design a way for it to work, right? Even if it's a larger unit than the commercial ones, it doesn't matter. We can figure it out.
Yep.
Thank you, guys. We have a couple more projects to go through, but just to give everyone an update on the filters, we did seek out and had about 4,000 yards of filter material on order. And that order was canceled by according to the manufacturer, by someone they couldn't refuse. So we're guessing FEMA or another governmental organization. And unfortunately, we lost that material. We're not able to get it. And they bought out all of their production for the coming year. So we won't, there's nothing in that well, unfortunately, at least for that product.
And can I jump in there quick on that?
What's that?
Can I jump in there quick on the whole filter discussion?
Sure. I would just want to give a really quick update, just that we had tried it, we had gotten that, and we need to. Do you have some new information on that?
Yeah. So for people who are a little up to speed or not up to speed on the chaos in the market, a year ago or 3 months ago, you could easily get filter material, you get N95 masks. And it's really kind of devolved to the point where anything in the supply chain is a mess, particularly filter material. The hardest those berries, the guys who really do N95 material are, as Dan mentioned, booked through, their production queues are booked through 2021, 2023. And so now people are looking in two other places. One is non-traditional N95 materials. So vacuum cleaners, diesel engine filters, which can be pretty risky. I mean, ultimately you got to test it on a test bed yourself. The other place I'm having, and I've been in this industry for years now, and all the guys that I typically use for filter material are like, forget it, Will, unless you can give us an order of 3 years and 10,000 yards a month, you're not, you're back of the queue. So now I'm also looking at overseas sources, and I have two coming out of Korea that are both N95 equivalents out of Korea. And those I'll get back to you by the end of the dawn, because that is major. And both these guys are like, look, stuff's locking up over here too. I would be a little circumspect to go in the non-traditional, like diesel filters and vacuum cleaners. These guys kind of talk out of both sides of their mouths saying, yeah, we tested on our internal equipment and it got N95. Get a sample and test that out, because it's really not that good. And two other quick notes. When you get filter material, filtration efficacy is one variable. The other two variables that are really important are tear resistance. So on the N95 product for Skylar, we're pushing it together like that. Some of this stuff's got the consistency of cotton candy, and it just won't hold up like that. And so a cheap adhesive given to it in any kind of rolling process, and it comes apart too easy. The other variable is pressure drop. So typically for a breathing one, you want a very low pressure drop, and that's where you're also paying the good stuff versus the bad stuff. So if you see something that's available, don't just assume it's usable just because they've got an N95. It could be a pressure drop. I have one here it's like sucking through a steel plate. It's horrible. So anyways.
Thanks, Will. Will, by the way, is one of the people who's been helping us with sourcing these materials because he's been embedded in that industry for a while. So thank you, Will, for that input.
I just wanted to cut in really quick. We just wanted to kind of work through all of the projects remaining, just so we can get to some Q&A. So,
yep. Thanks for being patient. So next one up. So we had some requests to do an intubation shield. We talked with groups of doctors, and there's intubation shields. There was a lot of problematic kind of feedback that we got on some of the products that were being made. Will and Brian, I think you guys are on. Can you just talk about kind of what your latest version of that is starting to look like? And try to keep it super quick. I apologize.
No, you're fine. Yeah, I'm one of Denver designer. We had kind of played with a couple different designs. A lot of it comes down to the shroud and what goes over top of the unit itself that protects the nursing staff and what have you in front of and behind them when they're actually going through this process. Some of the machines or some of the units were just basically an acrylic box that they put over the patient's head and shoulders to prevent spray from when they're coughing and what have you while they're putting in the intubation bulb. So we started looking at ways to make it so that it's easily put away, easily cleaned. Oh, there you are, Brian. Easily cleaned, but also easily put away and is fairly light and, something that can be easily moved out of the way if need be, because some of these are just unruly giant boxes that take up too much space. I'll let you, if you want to go into your particular design first, and then we can kind of go into the other one, Brian.
Yes, sure. So the first concept is something that can be quickly and inexpensively sent out immediately. So the first idea is a stainless steel rod that is formed into a frame, and then there is a clear plastic sheeting that goes over. And what this allows that the box does not is it allows you to access the patient at any place instead of having specific holes that you have to stick your arms through. It also creates a better seal. Although it's not a perfect seal, it's better than having just an open back. The second thing that this does is we have sourced a sheet that has an attachment for a vacuum, and what that does is it creates essentially a negative pressure inside, and our plan is to attach a vacuum to the sheet, and that will help to prevent any particulates from coming outside.
And then basically we looked at two different options. The other one was sort of a hybrid of that metal frame, but it also had a rigid component that would allow the vacuum to be attached, usually like a universal adapter onto the top of it, as well as that sheet that would go over top of it. So the metal frame would create a rigid structure for that to go over. And then basically it would have rigid holes for the doctor to put his arm in and out of so it doesn't bunch up in the process. And that both units would be allowed to be basically lashed to the bed, bungee cords or straps, so it won't move unnecessarily in the process. Second one we went through is a model that would be able to be broken down parts would actually be able to be popped off, cleaned individually, and also stored separately. So it's not as much of a hassle to have the giant box sitting around somewhere.
Yeah, and those.
If I can
those
share a screen real quick, I can. Go
Oh,
ahead.
yeah.
Sorry.
Cool.
Go ahead, Dan.
No, I was just going to say, so the next step is prototyping these products and being able to get them in for clinical testing. So they kind of are based on already the feedback that these guys have had a call with some doctors already to kind of identify some of the challenges. Next step would be get those prototypes created and over to Ken's team so they can start getting the doctors to check them out, give us some feedback, and then we can ramp up production. So I might have to skip it, unfortunately, Brian, if that's okay.
Okay.
Sorry. We still have one more project to go through, and then I really wanted to get get a chance to answer some questions. So the one other project that has it's on our radar, and it's one of our other teams that we've been trying to keep a close eye on. So at the very beginning of Make for COVID, there was kind of a coalition of different groups that were all working on different things. And Jeremy Beard, who is from Red Rocks Community College, he and his students were actually working on a ventilator valve system. And because of their work and how far along they were with that project, it's one of the reasons why we have not taken that on as our own internal project. However, we are keeping a close eye, as I said, and understanding how that project is going. So Jeremy, can you talk a little bit about where that project's at and how things are going?
Yeah, can you hear me?
Yep.
Thanks, Dan. It's good to see everybody on here. I haven't been too much a part of this. There's a lot of you though, with a lot of experience. It's pretty awesome to see all of the people come together. The ventilator components, what we did was we worked directly with, we had 3 hospitals we worked with. Anschutz was the lead on that. We worked with Good Samaritan Hospital as well and tested our prototypes at both hospitals. The company we worked with to manufacture our components was Respergen. And Respergen is currently in the process of taking some of the 3D printed items and running them through FDA approval to go through all of the steps to see how much off-gassing these 3D prints are going to have. What they don't want to do is have any of these prints off-gas, have them create some type of irritant within the patient's lungs, which would just exacerbate the situation. So we're running it through the entire FDA process. We were told that it would get fast-tracked, but the process could take up to 6 weeks. And this was 2 weeks ago when we submitted those. We're currently taking a look at doing some injection molding as well on those parts, seeing how many we could break apart, how many each mold we could make, such as your face mask. It sounds like you have about 1,000 of those. We're trying to see how many we can make using materials that are already FDA approved. But that's kind of where the project is at. The prototype is with Anschutz. That was where our last test took place. They had the equipment necessary to change the compliance on different lungs and to measure pressure and flow at patient. And so they're going through on their end with and the manufacturer we were working with, Respergen, is going through the process of getting everything cleared through the FDA and legal. And so that's where that piece is at. I know, Dan, you've been saying there's been quite a few people asking about possibly printing pieces off. Right now, that's on hold until we get approvals and run it through the regulatory process.
You were printing some pieces, correct? But explain exactly what materials and things you were using in that process, if you don't mind.
So some of the pieces could be printed off. And let me see if I can grab some of the prototypes we had. We were looking at for our early stages, the 3D printing store and a couple other companies printed some stuff off in carbon for us. So they used their SLA printers so that we could figure out the difference between the scaling for SLA and just stuff that was directly off of just our Lulz bots and things that. The carbon is one that we're sending through for FDA analysis to see. This material, we're told, can be autoclaved, so it makes it easy for them to disinfect. So they can just take all of these pieces and throw them into an autoclave machine, heat them up to a certain temperature, and guarantee that they're not going to warp. That was the primary concern. Some of the other parts, I don't know if I have any of them here. I think they're still at Anschutz. Some of them were pinching some hoses. So we had multiple valves we were looking at. And some of those pieces, if Anschutz comes back and says, yeah, we would like some of these pieces done, some of them could be printed off on the printers that we have. Yeah, I was just trying to see if we had any of those parts here. Some of the printers, some of the Lulz bots, some of the things like that people are using to print. Anschutz has taken the stance though right now, and it looks like and the hope was always right that we didn't have to use these ventilator pieces. It was kind of like a last resort option. These designs were because of capacity and because it looks like we're getting to somewhat of the top of our curve or bringing that trend down as far as cutting the top of that curve off, coming back down. If hospital capacities stay where they're at, they won't need to use the vent splitting systems, which is awesome. But it means that there are pieces then we might not actually need to manufacture. So we're kind of on the fence there, just on hold right now.
Yeah, you're ready.
We're ready. Yeah. And it sounds like a lot of you are too that can help out with some 3D printing. So as soon as I know more, we're definitely bring that back here and let you know for sure right away, Dan.
Thank you. Thank you, Jeremy. Thank you, everybody who was able to share these projects. So we do not have a ventilator in process right now because Make for COVID in general, we are trying to create products that are near industry level, and we're trying to create things that we can safely give to hospitals. I am certain that we have people in this team and in our community who have the capabilities of creating different parts of ventilators, creating ventilators at scale in a safe facility and in a way that we could ensure that they're going to have the QC that they need is a little further than we believe we're able to do as a group. That's not to say that we haven't looked at those designs and we aren't thinking, like Jeremy said, trying to be ready in case things do need to be spun up. But that is something that we are not actively pursuing at this time. Again, we're looking, we're keeping a pulse on those things, but those are challenges, frankly, that our group is going to have a real difficulty creating at scale and in a safe way. So everything we're doing here, we're trying to do in the safest ways possible. I know we're about out of time. I'm happy to stay on and answer questions a little later if anybody else would like to stay. And by all means, the team's here. If you can stay a little bit longer to answer questions, we really appreciate it.
And just a note on that, I know there's a lot of people you're seeing. We have multiple parallel pathways here, and at the end of the day, all of these teams, whether it's, I know I saw Karen on here doing sewing, or it's any of these projects.
Oh my God, I had Karen written down here and I skipped right over it. I'm so sorry, Karen. So that is a whole nother team that has been cranking through and creating some new products. Karen, can you talk a little bit about what the sewing team is doing right now?
Yeah, I'll spend just a minute.
So sorry.
No worries. I was off on other things looking for a DeWalt contact. So I'm just trying to we're frantically searching I know I spoke with someone. Anyway, so I'm Karen with the sewing team, and we are doing the back straps for the face shield. And this is one of our, we've ramped this up finally, and we delivered 580 to the warehouse this week. So that's our baseline 1 week production. So we're trying to ramp that up to 1,000, 2,000. These will go to the rural hospitals and some of the smaller orders, and nursing homes and the like. And we're also doing a sewn face mask version, a couple of versions of that we're going to see which we can get approved for. So as everything else here, we're looking for approved designs to get to our medical providers. So we've got a couple of those things in the pipeline, and also a scrub cap, which is potentially in the pipeline too. So we've got 3 things going.
They said, somebody said, Mark here said, "You are so awesome." Little pun for you. So, yeah, try not to laugh too hard there. There are some upcoming projects as well, besides these ones you've heard of. So as our requests that are coming in from the hospitals, we're starting to see different types of things that are necessary. And I'm actually working together with the safety team and making sure that we bring those challenges to our main community, because these are things that don't require FDA approvals, and we want to get everybody's ideas and brain power in order to come up with some good solutions there. So we have some upcoming things that we can't wait to involve everybody in. We want to make sure that they're done safely and we don't get our grubby hands all over them, but we have to get a little bit of instructions around those things first. So is there anybody that I missed? Any other teams? No? Okay. Thank you all for sharing that. Questions? Let's address some.
So we had a few dialed up just from the chat.
Should I scroll up there?
One was my understanding was that our 3D printing army was a stopgap until injection molding facilities got spooled up. Is there any idea of when that would happen?
So we do have some news on that front as well. So we do see our 3D printing army as that, boots on the ground stopgap. 2 weeks ago, we had a design that we could have gone to manufacturing with, and we heard from Genesis and from Virgin and from NOAA and from about 8 different companies that are all said that they were tooling up and they're going to be able to create tens of thousands of shields each within weeks. And to be honest, we're still getting lots of requests. We're still getting lots of people who need these products and who are not satisfied with the amount that are being created. In fact, we're getting increased requests. So we have actually as of this week decided to tool up and create a new prototype. Andrew, do you have that prototype there in front of you? I know you were wearing it while you washed your dishes tonight.
Yeah, hold on one second. Let me find it.
And just while Andrew's finding that too, I think, one of our goals is that if these injection molding facilities come online and the market floods with face shields or whatever it may be, there's still going to be a need, whether it be sheriff's office or grocery store workers. I mentioned on a state task force call earlier was, what about homeless populations? So there's always going to be a need somewhere that we feel we can help out.
Yeah, that's correct. So there's been a lot of feedback on all the different shield designs that have been out there. And I think what we've tried to do is create one that one to rule them all in terms of feedback and can be injection molded so that we can actually create it at scale. Andrew, do you mind showing some of those features?
Yeah, so this is, I just printed it, right? Like this is all Skylars work. But what we've tried to do is to take a lot of the best stuff that we've seen come up on the NIH website and to take feedback that we've had from the Anschutz Medical Campus's testing labs who've been testing all the shield designs that we've had. And so what you can see is just this hybrid version of the NIH kind of really popular shield mount design. You've got some really nice normalized Prusa peg styles, which fit with thousands of shields that were getting cut. And then I think importantly is that it's trying to solve a really kind of insidious issue with these, which are you have pegs and holes and these things you get splashed through if you get like a direct sneeze or something. And the closer those are to the eyes are known infection points for coronavirus. And so we're trying to figure out a way that you can basically make something that's not just horrible to print. So the reason we haven't pushed these out is that this took 5.5 hours to print, and it's a high probability failure part, and requires post-processing and things like that. But that you could incorporate some of the best things on the internet into something that you could injection mold. Because if we're not seeing the demand met elsewhere, then we feel a responsibility to try to meet it ourselves. But also, I mean, if I didn't say it, this is not my design. Skylar did all this work. So Skylar, multi-talented.
And even at that, it's kind of a mashup of a few popular ones out there. So yeah, it's pretty amazing to watch all the different designs come together and evolve into some cool stuff.
We've gotten to see a lot of feedback of all those prototypes. And so these teams, by the way, you know, while you've seen all this stuff that's on the internet, we've tried a lot of those designs or versions of them, and we've actually brought a lot of those things to hospitals and said, what do you think? And more often than not, they're kind of like, yeah, it's not as good as the thing that we can buy for $1 that we throw away, right? So we have arrived at this one product because it was received so well. Now this version will address some of the challenges that we've even seen come up with that design. So some other questions that we can cover. So just to put a cap on that one, we are tooling up as we speak to address that and to now have a lever that we can pull with our own injection molded face shields. And we don't have to keep you guys, poor Justin, you know, he hasn't slept in I don't know how long. This guy.
Yeah, my wife's not happy about that one.
Yeah. He used to be married, so
she's right here laughing at you. So we're at me.
No. So we while your products are still going to be useful, we're going to need you to start printing Miles enclosures for these PAPR pumps. So we'd like to engage you on some different projects and maybe start scaling back some of the crazy face shield production, but we're not there yet. So don't stop.
And on that note too, if there's anybody who has manufacturing resources, you can go to our head page or our homepage and click on Join M4C and choose I represent a company, and we're building a list of that for possible resources as well.
And Jeff Moe will get in touch with you like in 2 seconds because that guy is on it.
Did we, oh, sorry, I'm sure other people have questions.
Is there any that were in the chat that maybe I missed? Should I scroll back up, or did you guys pick some that?
Yeah, we maybe picked some out. A lot of them got. And this is more of a QA question, but is a QA team considering alternatives to the SOP for when we run out of either latex gloves or alcohol? That's just kind of for the 3D printing community, but
I can take that one. Well, or Jeff Moe can. He's the one who's been working on that. Is he on here?
Jeff Clipe, you're thinking for safe.
Jeff Creep?
No, but you've been talking to JL, haven't you, on the distillery front?
Oh, well, there's a couple things there. Yeah, in terms of getting alcohol, we're working on getting alcohol from some distilleries in Boulder that hopefully we'll be able to start distributing. And I think they changed the SOP, or it's been there for a bit, where using gloves and washing them with alcohol also serves a purpose. So you don't have to throw out gloves every time.
Rum, vodka, you know, there's a variety of things that work. All right.
All right, I have to correct Dan though. That's not true.
Well,
it needs to be like 106, like 140 proof minimum. Like, damn it, Dan.
Wow.
As we know,
It has to be Everclear, basically.
Yeah. Well,
Everclear. Yeah, exactly.
So Karen was great enough to get us a tour of Epilogue's factory. They have pallets of Everclear there that they use for cleaning instead of industrial alcohol.
All right, that's what they said.
Man, that was a lot of alcohol.
All right. Any other questions?
I was going to ask about, do we have extruded plastic manufacturers that we have as an option?
So extruded plastic, I mean, most of the plastic coming out of Plastic Care and some of those companies is extruded, right? Sheet extruded. Plastic in general is at a premium right now, and hard to come by.
What form were you looking for?
Well, it was just I had an idea at one point for one of the halos that would actually be made through a custom extruded die, and it would just basically extrude it through that shape and create the halo form. So that's what I was wondering if that was even a possibility.
I don't know what it would take to get that, set up. I know there is a company here in town who does their own custom extrusions. I'm not sure if they do them that large.
That'd be pretty big.
It would be a pretty big one. Also, the post-processing that would be involved with not only getting that piece, but then slicing it and then smoothing that, and then adding features to it and making sure that those were proud enough that we could add to it. That might be a challenge, but I haven't reached out to that company, but they are here in town. So yeah, I'll take a look.
Okay.
I know you presented a design around that, and I hadn't understood necessarily how that was going to work out, but I just remembered that company. So, any other questions? Man, that's amazing.
I had a question for Miles and maybe Will. So in our discussion for the Papper hood this week, we were talking about sort of the functionality of the folds of the hood, adding sort of a mechanical filter if someone coughs up, the germs aren't going to be able to get in the face. Is there any value to adding, what I'm imagining is the exhaust on the top of a roof, how you have the cover? Would there be any value in adding a mechanical filter to the Papper pump, or the sort of the air flow going into that no fluid would be able to touch even the filter inlet? Does that make sense? So you'd have
sorry.
inlet.
Oh, you're saying put in a sort of a tortuous route so that if someone had their back to the patient and the patient coughed, you wouldn't get splatter on it?
Yeah, or something that may add some additional mechanical filter as well as a paper filter. Yeah, exactly.
Gotcha. I don't know if that could be a great idea. You wear these things on your back. So my understanding, and I'm not a medical device designer, but my understanding is that it's less likely to get a direct hit. It's more for picking up the aerosols that get just distributed in the air. However, the 3M sort of industry standard for this application does have a tortuous path for its inlet. We'll have to think about it. That's an interesting idea.
Any other questions we can field? No questions is good, man. Means we explained everything perfectly.
Oh, I did actually have one. Sorry.
Oh man.
I know, it was at the end. Just a quick question. What battery are you speccing for the unit? Is it like an 18 volt or a 20 volt? I might have a Milwaukee.
So the basic stats, it's a 12 volt blower. So we just need to be up above 12 at the minimum voltage of the battery. So the current one that we have doesn't have to be DeWalt, but it's a 20 volt lithium ion battery,
Okay.
20 volt
Cool.
nominal. We do want this sled style design as opposed to the ones that have the big long like tube, because those are bulkier.
Okay.
And Miles, as a follow-up to that, how long would your battery last if the pump is going? Like, what's the power on the pump, and then how long would that 6 amp hour battery last?
So the max current for the blower is a little over 3 amps. However, the most I've seen it run is a little over 2 amps. So a 6 amp hour battery would, in theory, give us around 3 hours.
Yeah.
You know, in reality, it's probably a little bit less than that. So when we're looking for batteries, I really want to be at or above 6. We can go smaller and just give them a lot of batteries to swap out, but that's kind of a crappy solution.
Mm-hmm. I don't know when and where, but I was told 2 hours was a minimum. I don't have a rule on that for Pappers, but I remember seeing that somewhere.
I've heard everywhere from 1 to 4.
Yeah.
So the ER doctor that we talked to, Dr. Martin Krause, said that for this sort of specific crisis application, the longest he expected to be in a single operation or in a single intervention would be an hour. So he said, absolute minimum, it has to last an hour.
Yeah.
But I've also heard many other people say many other things. I'd rather err on the side of more capacity.
The OSHA test talks about maintaining a minimum pressure. I forget how many liters it was, but over 4 or 3 hours, right? Or 4 hours. So it's a pretty long time of continuous work. And most of these batteries are used to burst of usage. So we're kind of we're asking it to do something it's not necessarily used to doing. There's a question from Kyle Ronan. Is there voltage drop protection on the circuit boards?
So we have a voltage regulator, bucking regulator. So as the voltage drops in the battery, we still output 12 volts to the motor and 5 volts to the system, which is why we have to have the battery up above 12 at its lowest state. So there are some like 14.4 volt lithium ion batteries, and I'm less familiar with the different nickel, like NIMH and NiCad batteries. But as long as that minimum voltage is enough above that the voltage regulator can handle it, it should be good.
We had one question too on for 3D printing. What can we print on resin printers?
Well, we've been actually, John brought that up. I think it was today. Our enclosure might be a perfect thing to print on Formlab printers or something like that. So we're going to do the initial prototypes in FDM, but once we make the tweaks, I would love to get some volunteers and try on a fancier printer and see what kind of results we can get. Yeah, that would be super exciting.
Miles, just contact my team. We'd be glad to prototype and get samples out and do them at high quality as well for you.
Sweet.
So
yeah, and if anybody has a resin printer, I might need a few more of these too.
I don't know of anyone in our group yet, but I will keep an eye out for you.
There's
Go ahead.
Go ahead.
I was going to say that we're working on creating a task kind of board where we're able to start putting up kind of requests to the group as they come up, because it's hard to know or to be able to reach out to people directly with some of these asks, and they might come hot and heavy, right? So you just end up going to the person you know. So I think we're going to try and come up with a way to get some of those requests out into the website, or in a way that we can, anybody from any part of the organization is able to say, hey, we need this thing. And somebody from the community can check that task list and see if it's something that they can add their help to. I think that might help also, like Davis's question about makers with electrical circuits know how, as we get these kind of near-term needs, we're able to kind of kick it out to the community and say, hey, I need somebody who has some experience with this. And then we're able to immediately plug in. So right now, we apologize for, the missed opportunities we've had to work with many of you. But that is something we're trying to work a little bit better at and get a little more organized to handle those kinds of needs. It's easy to talk to the 40 or 50 people who I know who do some of these things, but when you have 1,800 members, you're bound to miss some folks and bound to miss a lot of talented people. So please bear with us as we fix that. Any other questions here? Yeah, Ethan, looks like we'll probably have to start collecting who has form labs and who has access to resin printers, and then maybe send out some requests.
Hey, Dan, I'm working on a list of who has what printers and what they're printing.
Oh, great.
So I will share that with you. I've shared that with someone else. I can't remember who. It's been a long week already, but that way we know who has what and who can best produce, etc. So
perfect.
Just so we can wrap up, so everybody can, do we have any final questions to ask? Want to make sure everybody gets something to eat if they haven't already, and get a good night rest to start working tomorrow.
Does it matter? This is Ty. Does it matter if I ask a question, or is it for?
Go ahead.
Oh, I was just curious. I'm assuming this is crazy, but would it be possible to like make your own filter material? It sounds like you would need some. I don't know how difficult it is. I was just kind of wondering.
That's a lot harder than it sounds. As I said, there's kind of 4 different properties with the filter material. One is obviously the filtration. 2 is the kind of tear strength of it, because you can get cheap stuff that's got the consistency of cotton candy. And then 3 is the pressure drop across it. So even if you could make something, it's hitting those other 2. Like when you end up paying $10 a yard for filter material, what you're really paying is those second 2. Most of the stuff is spun blown, melt blown, kind of high-end manufacturing. Mechanical filters, there's different types of filters, but maybe a mechanical one, I think it's a lot harder than it sounds. But yeah, I'd say if you want to take a whack at it, give it a go, because Colorado now has 2 facilities, both at CU Denver, and then now Boulder's got a facility with Marine Advances Lab that can actually test the filtration efficacy.
Oh, I see. Okay.
All righty. I think I'll go ahead and wrap it up now. And just wanted to pass along too that we are working on an updated SOP and FAQ, and we're going to try to focus on getting you all materials that are running low. We know something like alcohol is an issue for everyone. And we also did want to mention that we passed the 10,000 mark for face shield deliveries today. So good job, everybody.
Nice. Crushing it.
Awesome. Well, with that, we'll go ahead, Dan.
I was going to say thank you, everybody.
Alcohol.
Yeah, that's right. We'll use Davis's recipe here for some drinks tonight. What was it? Let me look at that. Yeah, 3 cups, 190 proof, 1 cup of water. Yeah, so enjoy that.
The Make for COVID special.
Make for COVID martini.
You can use alcohol to disinfect as long as it's not Merlot.
It's the SOP martini, I should say.
The blind cider.
All right. Thanks, everybody.
Have a good night, everyone. Thanks.
Good night.
Thanks. Good night.
Night.